Welcome to the Explainer. Today, we're diving straight into how the physical and electrical environment is literally the ultimate decider of your network's reliability and call quality. It's incredibly easy to get completely swept up in the software configurations, those multi-level IVRs, and the gigabit speeds of a system like the REX IP PBX. But honestly, the truth is, the most advanced telecommunications hardware in the world will absolutely crumble if the physical space it lives in is fundamentally flawed. So today, we're going to unpack the manufacturer's exact specifications to help you build a truly resilient, fail-proof environment for your communication tech.
Here's our blueprint for today. We'll be looking at the ideal equipment room, defeating invisible enemies, step-by-step safe wiring, and finally, the foundation of grounding. All right, part 1, the ideal equipment room. Let's talk about building that physical foundation. Think of a baseline, pristine, standard server room. We're talking completely empty floor space, a total lack of clutter. Your equipment's survival demands this strictly controlled environment. And this isn't just a polite suggestion from the manufacturer, it's a foundational site requirement. A server room is not a storage closet, right? Bringing in boxes, office supplies, or just random unrelated items introduces dust and potential physical interference that will directly impact both the lifespan and the performance of your PBX system. So the real trick is balancing these strict operating bounds against hazardous extremes. In your comfort zone, the equipment room absolutely must maintain a temperature between 0 and 40 degrees Celsius, with humidity floating between 0 and 90%. Keeping things dry and well-ventilated is mandatory. But then you have the absolute do-nots. You have got to avoid direct sunlight, heavy vibration, dust, and any potential contact with water or oil. Furthermore, keep this gear far away from radio and cell phone antennas, electric welding machines, or high-frequency machines. Why? Because their electromagnetic interference will literally shred your signal quality. I really want you to lock this number in your head right now, 40. That's 40 degrees Celsius. It is the absolute maximum limit your equipment can endure before the ambient heat becomes a critical threat. If your room's air conditioning fails and that temperature creeps past 40, your hardware is essentially baking in a sauna. At that point, unexpected system shutdowns or permanent costly hardware damage are practically guaranteed. Moving right along to part 2, defeating the invisible enemy. It's time to battle heat and AC noise. To actually survive and breathe, your device demands a minimum 1U buffer zone from other equipment. For anyone who might not be super familiar with the terminology, 1U stands for 1 rack unit, which is a standard measurement for server racks, coming in at about 1.75 inches of vertical space. Physical isolation is an absolute must to let the hardware safely dissipate heat. You have to leave those empty slots between the hardware units. Stacking devices directly on top of each other, like pancakes, creates a localized heat trap which completely nullifies your room's air conditioning. The heat generated by the devices just has nowhere to go, and that raises their internal temperature well beyond that 40-degree ceiling we just talked about. But heat isn't our only invisible enemy here. AC noise is an insidious force. It can completely destroy call quality by introducing static, weird hums, and dropouts. You have to actively defend your lines. The rules are super strict. Never run your telephone lines parallel to AC power supplies, computer lines, or other data cables. And definitely never share the same power socket. Now, if you're in a bind and absolutely must run lines near potential interference sources, you have to insulate them. The manufacturer highly recommends using shielded twisted pair, or STP cables, or utilizing conductive adhesive tape to physically block that interference from reaching your voice data. Let's talk power for a second. Your power supply has to be rock solid. The equipment operates on an AC voltage of 100 to 240 volts, but the critical takeaway is independence. Your PBX system needs its own independent power supply, totally separate from other heavy equipment to prevent unneeded interruptions. And listen, if you're operating in an area where the local power grid fluctuates or drops out, you absolutely must install an uninterruptible power supply, a UPS, to stabilize that AC voltage. Sudden, violent voltage fluctuations can and totally will bring your entire network down. Okay, part 3, step-by-step safe wiring. Let's manage those network connections. Think of those physical cables as the actual arteries of your entire system. You could honestly have the most brilliant configuration settings in the world, but any single misstep in the wiring directly degrades the end user's call experience. It's simple. Shoddy wiring equals a shoddy network. So here is your essential survival checklist for safe wiring. Step 1, always cut the power first before you begin wiring, and only turn it back on once you're fully done. Hot wiring causes immediate system malfunctions. Step 2. Ensure that one-use spacing for heat dissipation before you lock the device into the cabinet. Step 3. Isolate your voice lines from AC power and use that STP shielding we mentioned. And finally, Step 4, which is a major safety protocol, if you are performing high-voltage protection, you must position your lightning protection distribution frame appropriately. That usually means mounting it about 2U higher than the device itself to facilitate safe, organized wiring.
Once the device is safely mounted and protected, it's time to optimize the external connections. Keep the lines connecting the device to your patch panels short. Around 20 centimeters is pretty much ideal. Every single external line must be completely tested because analog external lines directly dictate the customer's call experience. The golden rule here: simplicity. Avoid using unnecessary external devices like extra dialers on the front end, and double-check those line connections. Is there a random junction box sitting in the middle of a run? Because every junction box is a potential point of failure that degrades communication quality. If the line is long enough, just eliminate the junction box entirely to keep that signal pure. When we talk about a standardized, clean installation to a distribution frame, deliberate routing is what makes it work. Connecting the RJ45 ports on the front of the REX to a PT2400 or PD4800 patch panel using straight-through Cat5 cables should be neat and organized. Avoiding a chaotic tangle of wires is exactly how you prevent system errors and actually make future maintenance manageable for your team. Finally, we hit part 4, the foundation of grounding, ensuring both safety and quality. It is honestly kind of fascinating that a massive, multi-million-dollar communication setup entirely relies on a simple yellow and green wire. But it really does. The telephone exchange must be reliably and consistently grounded. Why? Well, for one, the quality of your calls is vastly impacted by it. But far more importantly, it is what protects your staff from sudden electrical surges. Proper grounding isn't optional. It's a non-negotiable safety and performance requirement. This right here is arguably the most important metric of your entire electrical installation. 3. Your resistance to the ground must be less than or equal to 3 ohms. It needs to be grounded separately and thoroughly, fully complying with standard communication equipment grounding rules. If your resistance is tracking higher than 3 ohms, your system is highly vulnerable. But what if you are deploying in an older building that completely lacks proper standard grounding conditions? Well, the manufacturer explicitly outlines emergency grounding tactics for this exact scenario. You have to get physical. You'll need to choose a suitable location and literally drive steel nails deep into a solid wall, or go full MacGyver and drive a nail directly into the earth itself to secure a temporary grounding source. That is how critical this is. You absolutely cannot run the system without giving that electrical energy a vital escape route. So as we wrap up this explainer, I really want you to ask yourself if you've properly respected the physical parameters we've outlined today. Is your multi-million-dollar network actually built on a solid 3-ohm foundation? Have you accounted for those invisible elements like 1U heat dissipation, AC noise shielding, and strict temperature controls? The software capabilities of your IP PBX are no doubt incredible, but they're only as reliable as the room, the rack, and the ground they are bolted to. Ensure your foundation is rock solid, and your network will absolutely thrive.